Carmen Greenwood, Ph.D. professor and insect ecologist at SUNY Cobleskill, has been working on insect conservation for 15 years. Tonight, we will learn how a dedicated team of researchers is working to bring back the American burying beetle to its historic homeland. Welcome, Carmen. I'm going to stand here so the Zoom people can hear, but thank you very much for having me here today. I'm going to talk a little bit about the project that we have going on. As Becky mentioned, right, we've been doing this for a lot of years, and it's actually getting to a point, we think, where we'll have success. The project's happening right here in your own backyard, so I think it's very nice, right, that I can talk to this group. And it also has a very important link to bird conservation, which I think is even nicer for the Audubon Society. So a little bit of background about American burying beetle. This is a picture of the beetles right here. These are beetles that did used to live here all throughout the eastern US. I'm going to show you a little bit about their history, their range. They were last seen in New York probably around 1960. And that's not the only place, of course, that they've disappeared from. And they're kind of iconic. They're one of the first, if not the first, insects on the endangered species list. So they've received a lot of attention because of that. And I'm going to tell you a little bit about what that has involved as well. So this project is funded by the U.S. Fish and Wildlife Service. They are part of the Endangered Species Act, and they're the people who monitor that. And we have a huge number of collaborators. So I have a few people up here, Dr. Melissa Fierke, Roger Massey, who has worked with you before. He's our bird contact, Matt Schlesinger with the New York Natural Heritage Program. John Pepino is my project manager. And then there's a bunch of other people involved as well. So let me see. I found this the other day. I was talking to Roger Massey about bird conservation. And it's kind of interesting that birds and insects would be promoted together, you know, the conservation of them. And I also read that most of our North American birds eat insects, right? Or many of them like to eat insects. So insects are important for them. So in this case, we have a beetle who eats birds. so kind of the opposite situation, but still critically important and still a really good excuse to conserve bird diversity. So I'm going to explain how that happens. It does not kill birds. So just to relieve everybody's minds here. The American burying beetle has been the subject of controversy, and I think that has a lot to do with where they occur. So I'm going to show you some of the places where they still occur. So you'll see articles like this. I think this came from the Washington Post, maybe. But American burying beetle got in the way of oil exploration. It got in the way of corn expansion. And it got in the way of big industry of several forms, which has caused it to be a subject of controversy in the past. Okay. But it is also the biggest, kind of the apex species of its guild, which makes it also kind of an umbrella species. You can protect a lot of things by protecting American burying beetle. We have a Facebook page for this story. So if you want to follow what's happening with the reintroduction, feel free to check out the Facebook page. And on the Facebook page, you can see pictures of our brand new beetles. We have our first generation of New York beetles coming out of their pupal cases in the lab right now. It's very, very exciting. So if you go to the Facebook page, you'll see lots of pictures of them, and we're pulling them out every day. It's very, very exciting. John Pepino made our logo. That's that little picture in the corner. So that will come up probably a couple times as well. So a little bit about American burying beetle, its biology, its background, things like that. That big, beautiful beetle in the center that somebody is holding that has a number on it, that is an American burying beetle. Each one of them gets a number because each one is very special and very few. And it belongs to the family of carrion feeding beetles. So this is a beetle that eats dead things. It eats carrion. And the little pictures that you see over on your right are other burying beetles. These are burying beetles that still exist. Here in New York State, we frequently see them. They all tend to be smaller than American burying beetle. And the third one from the top, Nicrophorus orbicollis, is probably the one most closely related to American burying beetle and closest in size and in biology. And we use that beetle as kind of a surrogate to determine habitat suitability. If we want to do behavioral research, we usually use the surrogate instead of actually using American burying beetle because, of course, they're very sensitive. I'm going to tell you a little bit about its biology. All of these beetles feed on carrion. And the family Sylphidae, big family, hundreds and hundreds of different species. They're all carrion feeders. They eat dead things, but the genus Nicrophorus is the genus that includes the burying beetles. So in addition to feeding on carrion, they require a dead animal of appropriate size as a reproductive resource. They will bury a carcass under the ground, a single male and a female, and use that as a brood chamber to rear their offspring. And so that is probably the most important thing when it comes to why we saw their decline when we did, what we need to make sure, is on site for them in the future. This is kind of a little bit about their life history. It's not very glamorous, but they find dead things on the landscape. Males will usually find these carcasses first. The type of carcass is not that important. It could be a small mammal, could be a chipmunk, a squirrel, and very, very often a bird. Birds of maybe about 100 to 200 grams in size. So we're talking about things like doves, chipmunks. Most of our upland game birds will fit in this category. Bigger than songbirds, but many, many different birds serve as hosts for these beetles after they are already dead. Once the male finds a carcass, he calls to a female with pheromones. The female beetle shows up, and the male and the female will process that carcass. They'll trim all the hair and feathers off of it. They'll coat it with secretions to reduce bacterial decomposition, and they'll bury that carcass under the ground, and they'll do it all in a matter of hours. Yeah, it's an amazing behavior. And they can tell the size of a carcass. There's been some really interesting behavioral work on them they walk around it repeatedly, and this actually they can measure the carcass, and it stimulates them to start reproducing. So very fascinating behavior. They're also very well known for biparental care, which means that the female, once the carcass is buried, the female will lay eggs near the carcass underground. And once the babies hatch, both the male and the female will stay and take care of them. The male and the female will feed on the carcass, and they'll regurgitate food. That's what you see happening in the top picture to the babies, just like a mother bird, right? They squeak and they call for the mother, and she comes and regurgitates food to them. And the male will do it too. So this is kind of unusual in insects to have both parents stay with the young. Once they mature, they will move off and into the soil to pupate. And I do see if it works. I just have a picture. Oh, they may not work. I have a picture of them chirping and being fed. I don't think it's going to work on this though, because the picture isn't there. I'm sorry. Let's see. Oh, maybe there it is. There they are. Yeah, so they squeak and the parents come over and they feed them. And yeah. That yeah. So so I have this picture left in just to kind of illustrate. These beetles are a perfect example of resource partitioning. All those different carrion beetles that I showed you that are different sized beetles require different sized hosts for reproduction. So it's a perfect example of resource partitioning that reduces competition between them. Just like we often see with different birds, right? They have different nesting habits, different feeding habits. And one thing I always think is interesting when I talk to my bird friends, when it comes to insects, it's all about the wings and the mouth parts. And with birds, I guess they have different beaks, right? Different wings. So there's a lot in common there. So when it comes to reproductive hosts, this is supposed to just kind of show these different species of bearing beetles across the bottom. We have tomentosis, this little tiny one with the gold fur on its back. That's one of my favorites. Orbicollis, Americanus is at the big end of the scale. There's actually a few other species in between. And each one of these beetles needs a specific size host for reproduction that they bury under the ground. They'll eat anything, but when it comes to reproduction, they're very specific. So that's an important factor when it comes to trying to reproduce these or to release these. Do we have the hosts available? American burying beetle used to exist throughout the eastern US. It also existed into southern Canada, eastern Canada. And it disappeared from the US pretty across the landscape, pretty much around the turn of the 20th century, right around the early 1900s. And that's when we saw just disappearance of American burying beetle everywhere. And it coincided with the disappearance of a lot of other things. So at that time, we lost a lot of important species, including one that's thought to be probably its most important reproductive host. Yeah, the passenger pigeon. And we lost a lot of other things at that time. There's only 3 remaining populations. The 2 that are, we were just talking a few minutes ago about being, right, there's only 1 population east of the Mississippi. The 2 prairie populations, one in Nebraska, one in Oklahoma. Both of those 2 populations are under threat. The Oklahoma population is under threat from oil exploration, drought, climate change, and also invasive species. Fire ants are moving north, and it really can't deal with fire ants. So that population is disappearing from the bottom up. The Oklahoma population, I'm sorry, the Nebraska population was really cut in half with corn expansion for when we had the big biofuel thing in 1990s. They really chopped up that population, so it's much smaller than it used to be. And so the Fish and Wildlife Service has a recovery plan. And according to their recovery plan, they do expect these other 2 populations to probably go extinct within the next 100 years. And their goal is to try to save that northern population out there that's on Block Island. That's our population. And we're trying to bring it to the mainland. And their goal is to bring it to the mainland somewhere in the Great Lakes region. And that's probably the only hope for the species. It's also genetically distinct from the prairie beetles they have found recently. So another reason to really pay attention to this island population. This is some of the current status of it. It's really anything in blue is extirpated. The areas that are in red and brown are critically endangered, and there are some confirmed sightings, some unconfirmed sightings. But basically, it's kind of a repeat of what you just saw. And so that's what we're working under is the recovery plan from the U.S. Forest Service. If you look at our history in the United States back around the early 1900s, this was kind of the peak time for deforestation and agricultural expansion across the US, right around 1920. We saw the loss of a lot of different species, right? American chestnut, passenger pigeon, a decline in some important host species also. Prairie chickens, bobwhite quail, turkeys. Turkeys, which seem fairly plentiful now, I guess. Were not terribly plentiful at this time, right? They kind of bottomed out during that period. And turkeys are big, but turkey poults are actually very good size for reproductive hosts. And I hate to say this, but they all have pretty high mortality as youngsters. And so these are thought to be important reproductive hosts for burying beetle. In the West, prairie dogs were wiped out by the millions to make way for cattle expansion. Again, perfect size reproductive hosts for burying beetles, but nobody thought that was important at the time. And along with the loss of reproductive hosts, we lost a lot of our top predators, which allowed for the things that compete for these reproductive hosts to increase. So having more raccoons and possums and skunks and things like that that eat the dead animals can increase competition for the reproductive hosts. So these are all things that happened in the past. Most people kind of agree that the bottleneck for reproductive hosts was probably the most limiting factor for these burying beetles, along with competition for those hosts. And there's also a lot of competition for those dead animals from invertebrates. It's a great resource on the landscape. Lots of things eat dead things. And one that I'm particularly interested in that I think might be an important factor is the group we call filth flies, house flies, blowflies, flesh flies, things that come to the dead animals very, very quickly, colonize it very quickly, and have increased dramatically with human expansion. Anywhere you have humans, you're going to have a lot of flies. It's just the way it is. And an interesting side note when it comes to burying beetles is their defense. And I don't have a picture of them, but I have a picture showing later. Burying beetles carry mites on them, on their back, phoretic mites. And when the burying beetles, and most of these dung beetles also carry these mites with them. And when they arrive at a dead animal, the mites disembark, and the mites are predators of fly eggs and fly larvae. So yeah. And so if the beetles get there early enough, their mites can disembark and clean off the fly eggs and the maggots, and the beetle can still bury the carcass. So it's a symbiotic relation. It's been described as a symbiotic relationship. That's really, really interesting. So how do you even do a project like this? I started in Oklahoma. So I worked in Oklahoma State for about 10 years before moving to New York. And I'm originally from Michigan, from the UP of Michigan. So I really wanted to get back north after living in Oklahoma. And and most of my work was on burying beetles in Oklahoma. And then I started really paying attention to that northern population. And it worked out that I was able to move up here and work specifically on that population. And so what I wanted to do was help the Fish and Wildlife Service, which is what I was doing in Oklahoma State with the population down there. But to help them get that group, the population on Block Island, to the mainland. So we put together a project where we wanted to look kind of at different parts of the state, find good habitat for these American burying beetles. So we surveyed different sites. We came up with a suitability matrix based on the needs of the beetle and what was known in the literature. And we started to survey, and we surveyed many places all over the state for about 4 years, put the data together, submitted a proposal, and we got funded to do this reintroduction project. So we're pretty excited about it. and it's been a long time in the making. So we've looked at a number of places around the state. Those stars are a few of them. They're not all of them. But mainly we're targeting different regions, different habitat types. And you also need to have land, kind of a large area of land that's protected, that will be amenable to this kind of project. So we've worked with a number of conservancies, including Greenwood's Conservancy in Hartwick, which is one of our #1 choices, actually, based on our survey data. Yeah, right here. The Hike Preserve, we've also worked down there. We've worked in that part of the state. And one area that's also really interesting is up near the Tug Hill region. And our next plan is to actually work with some of the tribal lands and survey some of those up in that region. And they also have interest in conservation. So that area up there is really nice because of the soil types for burying, the heavy snowpack, which helps to insulate the beetles over the winter. And then there's some vegetation characteristics, native bunch grasses, heavy population of oak trees. All of our hosts tend to do really well with oak or some other trees that provide mast. So this is an area that we're very, very interested in for 25 and 26. Right now, Greenwood's Conservancy is our primary reintroduction site. We're hoping to do this reintroduction in June of 25. We are rearing beetles in the lab right now. We have our first generation of New York beetles, and they're beautiful and shiny and healthy. You can see them on the Facebook page. And Greenwood's Conservancy, we've done surveys out there for 4 or 5 years now, I think. And what we typically do is we'll put our beetle traps out in a grid across the conservancy. We have 12 traps. Beetles are really good at smelling a carcass. So they can smell a carcass from about a mile away, and our traps are baited with a carcass. So the Fish and Wildlife Service has a protocol for trapping beetles, and we place these beetles at least a half a mile apart. And we kind of targeted the different habitat types that are available at Greenwoods just to see if there were any differences or where might be the best place to do our reintroduction. So what we're catching in these traps is obviously not American burying beetle because that's not here. But we are catching the other species, those other pictures that you saw. And the one we're particularly interested in is Nicrophorus orbicollis. We consider that to be our surrogate beetle. The body size overlaps a little bit with that of American burying beetle. Very similar biology, very similar host requirements. It's also nocturnal, just like Americanus. And so we're looking at the abundance of orbicollis and the size, the body size too. But we also want to get a baseline sampling of all the burying beetles so that we can see how that changes once we add American burying beetle to the mix. I will note that all of those species do coexist with American burying beetle where American burying beetle still exists. So they do manage to live together without competing each other. But we do want to see how that community shifts when they're introduced. So this is how our trap works. It really is a 5-gallon bucket with a little bit of peat in the bottom and a landing pad on top because these beetles fly. That rain guard covering up the funnel. And the trap is tied to a tree so that the coyotes don't carry it off. There's nothing we can do about black bears. They will rip those things off the trees and chew them up. But it's pretty good for other scavengers. The beetles will land, they'll fall through the funnel, and every morning we check the traps. We document what beetles are there, we measure them, and we let them go. And that's a couple of students checking beetle traps right there. Traps are checked daily for 5 days and then rebaited. So a carcass maturing and carcass aging and stuff like that is really more of an art than a science. But we try to get those carcasses just right. We take them out of the freezer, we thaw them, they go through those stages of rotting, and they're really good for about 5 days, and then they're not so good anymore. So we rebait and start the process over, and it's very interesting. These are students checking the traps for beetles, and they're measuring the width of that shield right behind the head, the pronotum. That's a real standard measure of condition for insects, just like you probably have some for other animals. And then we document the abundance of each of these different types of beetles. So Orbicollis pustulatus, tomentosus with the little gold fur, Sei and Daffodians are typically found. This is from Greenwoods. These are common at Greenwoods. The 4 different colored bars represent different habitats. So if I can see this with my glasses. Oak and oak is a gray bar, and mixed forest is an orange bar. The yellow bar is kind of early successional or shrubland. And then blue is the open fields. So you can see our surrogate species, Orbicollis, is most common in oak forest and shrubland, which is also ideal habitat for a lot of these hosts. Upland game birds, little mammals, chippies, squirrels, things like that eat acorns, perfect habitat for them. So tomentosus, in addition to partitioning themselves by reproductive host size, they also have different peak activity times. So another way that they don't outcompete each other, which I'm going to show you at the end, Sei comes out first. They're usually out in April, reproducing, bearing hosts. Little tomentosus is usually at the end. They don't get to come out and reproduce until about August or September. And Orbicollis tends to be June and July. So that's another mechanism that they use to partition themselves. The measurement on the y-axis is a way of standardizing our data. So we measure trap night frequency, number of beetles per trap per night. And that way we can compare multiple studies. You know, you might have different number of traps or different number of nights, but you can have a similar way of looking at their relative abundance. Fort Drum. We were able to survey up at Fort Drum, mainly to get that Tug Hill type habitat. Amazing habitat up there. They have oak savannas and oak forests and grasslands with native bunch grasses, and that wonderful snowpack to insulate the beetles. And we found very high trap night frequencies of our different burying beetles up there. So that's why we're going to try to work with some of the tribal lands up in that region, starting this year, next year, hopefully. So part of this survey that is really important to reintroduction is knowing that there's reproductive hosts available. So I've been fortunate to work with Dr. Roger Massey, who a lot of you probably know. He's one of our collaborators. Dr. Amy Decken-Quinn started the small mammal surveys. John Pepino is doing those now. And so we're looking at all of the potential reproductive hosts. We survey for those as well. And that includes all the small mammals, game birds. We're collecting a little bit of hair or feathers from each of these so that we can do a stable isotope analysis. And what we do with those is we match them up to beetle samples to find out what beetles are actually using as hosts. So really exciting new technology for deciphering food webs that we think will be helpful for this. So Roger's work. Roger comes out to our sites. He does point counts. He teaches the students how to survey. And this is just one of his years. He's done this every year, showing the students how to document bird abundance. And of course, Roger's real interest, I mean, his other interest besides burying beetles is American woodcock. And he's very interested in upland game bird species in general. And so he's been documenting that at some of our sites and comparing that to national averages and focusing on things that are of reproductive host size. So there's great game birds at Greenwoods. You guys probably already know that. And other things too. So these mourning doves, the jays, the corvids, things like that. He documents the diversity. Some of these are too small for American burying beetle, but they're good size hosts for the smaller beetles, which gives them, something to use when American burying beetle is here. Same thing with small mammals. So we, study what could influence the populations of these things. Oak mast is turning out to be really important for a lot of these different host species. Also the heterogeneity of the landscape. They like to have kind of a patchwork habitat for different purposes. So when it came to small mammals, we used the same sites where we had beetle traps. This other picture, I think, is from the hike preserve. And we set out grids of live traps for small mammals. 50 traps at a time. We do this 3 times over the summer and document which hosts might be available. And so this is some of Amy's work. Dr. Quinn worked some of her work on the richness and abundance of some of these small mammals. The other things that we are addressing as part of this study are the factors that really impact the viability of introducing American burying beetle. So some of the main sources of mortality for these burying beetles, one of them is overwintering, and that's been studied on Block Island. It's cold, right? They see up to 70% overwintering mortality, kind of on a regular basis. It's normal. So we're doing some studies at Greenwoods. This is why we're really interested in things like snowpack. John Pepino just finished his master's degree, and this was the focus of his thesis, was looking at factors that impact the viability of American burying beetle. So this was actually his work. He actually completed 2 different studies. So one of them was competition for carrion, reproductive carrion, not food carrion, reproductive resources. So he did an extensive study where he put carcasses on the landscape of different sizes, appropriate sizes for different beetles, and then documented what happened to them. And we had 3 categories. They were either taken by a vertebrate, that's a category. They were colonized by fly maggots to the point where a beetle couldn't bury it, or it was buried. And he did this, he actually completed this twice, which is very interesting. And so what he found was that depending on when you did this, so this was a figure from July, the yellow part of the pie was colonization by fly maggots, and it was 56%. And I didn't bring the one from June, but what was really interesting is in May and June, it was completely reversed. So he had 70% of his carcasses buried by beetles. And so there was a really strong correlation with temperature. And as the temperature gets warmer, not a surprise, I guess, flies get more active, more quick to get there and colonize. And so as the summer went on, flies became more and more of a threat. And this is really interesting and important, I think, for us when we think about climate change and what's happening, over the long term. American burying beetles right now tend to find their hosts in June. And if they do that, if they can, they're pretty plastic. If they can find their hosts and reproduce early enough, they might still be able to compete with flies. But if we see these warming trends, flies may become more of an issue. So those are just lovely pictures of his study. We'll move on from those. And this little graph just shows the seasonal dynamics of these different burying beetles. It's not a pretty graph, but Each different color line is a different species of burying beetle, and it shows across the bottom axis is time going from early May to late September on the right. So the first beetles to get active, the orange ones, are Nigrophorus sayi, come out early. The big blue peaks in the middle are Orbicollis, our surrogate. And then way in the end, the little gray peaks are going to be Tomentosis, the little tiny beetles that have to wait till everyone else is done to get their hosts. And so it just kind of illustrates how complex their biology is. It's a very intricate system, a lot of variables involved. And our goal, we have to try to study all these variables, but we're trying to establish multiple sites. So we have a meta population of American burying beetle. And, you know, that they can actually interbreed with each other. Actually, I got a better slide of that right here. They can interbreed with each other, provide a little bit of connectivity. They're very mobile. So our American burying beetles need a big, wide range. So having multiple sites, I think, will help with that. And that's our goal. We're planning to continue monitoring, finding new sites. We're trying to renew the project for another 5 years, starting in 26, which I think we'll be able to do because the Fish and Wildlife Service has been pleased with our work so far. And we're hoping for that first reintroduction in June of 25. The proposal is open for comment right now under public comment from the DEC. We appreciate positive comments, of course, because once that comment period is over, there will be a hearing to approve it on July 9th, and we're hoping that that will go forward. And that the Endangered Species Act will continue. There's been a lot of attacks on the Endangered Species Act in the last few years, so we're hoping that that won't influence our project either. And I think, yeah. And that's the end of the formal presentation. So I tried to think of all the people that are helping. It's really hard. There's so many people involved. But I'd be happy to answer questions. I know I went through that fairly quickly, but it is a complex system. So if anybody has any questions, I'd be happy to answer questions.
What's your lifespan?
Probably a little over a year.
So you say they overwintered.
Yes, they overwinter as adults. So typically they will emerge as a brand new shiny adult in the summer. They'll overwinter and then come out and reproduce as a brand new adult. But we have found old beetles that have overwintered a second winter. I don't think they live very long after that. And we have found that beetles can produce a second brood sometimes, which our beetles are doing in the lab right now, but usually it's still in their first summer. So usually a year or a little longer, maybe. Yeah.
What mechanism do they use to bury the hosts? Do they tunnel under the?
Yeah.
Drops in a hole?
Yeah, they excavate. Yeah, so it looks like it's just kind of melting into the ground. Kind of like some of our local dung beetles do. They excavate from underneath and the carcass just melts down. We have time-lapse footage of it on our Facebook page. Yeah, because we have a glass rearing chamber, so you can actually see the thing happening. We sped it up. It's kind of neat. I can pull it up. We could all watch it. And they can carry the carcass. They can carry it a little ways. If the ground isn't good for burying, they'll actually drag it a little ways off and bury it. Yeah, a male and a female. The little tiny gold ones, the Tomentosis, some of them will actually breed communally. So sometimes you'll find like 4 or 5 pairs of them working together on something big. I found a bunch of them working on a skunk one fall. There were like 6 pairs of them all working on this to bury this skunk together, which was really cute. And
Is it common among insects that adults feed the larvae?
No. Yeah, it's not. There's a few of them like our truly social insects, like honeybees, right? Where they stay, they protect them and they feed them. But no, it's not terribly common. And this is really important because they need to have certain symbionts to be able to deal with rotting flesh. The carcass, they need to have the stuff they get from the parents in order to digest that. Termites, right? Termites do that so they can get the symbionts they need to digest wood. But it's not real common, no.
Do they have any predators when they're reproducing? Is there anything that will go down and go after the larval form?
Oh, I'm glad you asked that. So, that orange coloration on them, most people will say it's aposematism. That means they're advertising that they taste nasty. And they are foul. They have a defense. If something comes after them, they spray like a skunk. And it's like this mixture of cadaverine, compounds from the carcass. It is really foul. But we did catch one time on our trail cam. I think it was a possum. It's either a possum or a skunk. Found the carcass and it was eating the carcass and we watched it on the trail cam just munch the beetles along with the carcass, just chewed them up and swallowed them. So I don't think it was intentional. He's eating the carcass, obviously, but I think that's why the beetles coat the carcass to try and hide it. They coat it with secretions that reduce the smell, reduces the bacteria, to try to keep those things from smelling the carcass. Because I think that's how they get eaten. Things are eating the carcass. The beetles themselves, I don't know if anything would eat that. When you pick one up, I don't know. I've never seen it happen. I don't know I'm not saying it wouldn't. They're pretty big too.
Not the larvae would be.
The larva
Would be very attractive.
I think the larvae, the larva would be very vulnerable. I agree.
But
And
if the beetles are nocturnal, that might reduce predation.
yeah, except by these mammalian scavengers, right? Oh, I should stand here, sorry. Yeah.
Monitor them the same way you're checking traps now.
Yes, yeah, that's our goal, is to see the whole community, to see how the whole community does after the reintroduction.
Right.
Oh, yeah. Oh, yeah, we will mark them. We have a marking system, so we can, track each individual beetle. That little white tag that I showed you that was on the wing on the elytra, that was a bee tag, and that's how they tag bees. That doesn't work very well with American burying beetles. We now have a system where we use a brand. It's a little hot metal wire, and you just touch it to the orange spot, and they get a little brand on them that tags them so we can mark and recapture them. And every one of them will be tracked. Yeah.
Did you put GPS?
We are waiting. The technology is getting smaller and smaller and smaller, and people have tried it, and it still weighs them down. We need it to get a little bit smaller, and as soon as we can do that, we'll do it. Yes.
So what are the numbers that you plan to release?
So we're hoping, right now with our new generation, we have about 170 beetles, which could equate to about 80 pairs, maybe 80 breeding pairs. And we will release as many breeding pairs as we can, because it's really hard for them to find each other. Yeah. Oh yeah. Yeah. That picture, it's not there. That picture, the front of their face is different for males and females. And it was on the title slide. You could see it really clear, that little patch on their face. It has a different shape for males and females. And you can sex the other ones also. Yeah, there we go. There. Yeah, one has a square, the female has a little triangle, and the male has a big square on the front of his face. Typically between 10 and 30 larvae per brood. We've been really lucky with our broods. We've been averaging around 20, low 20s maybe with our broods. And a single and a female can rear them on her own. Sometimes a male takes off. It's not very often. Usually he stays and helps her rear the babies, but once in a while he'll leave and the females can still manage to breed to we had a female who just did it. She raised like 25 babies, and as soon as they were mature, she died. It was really sad, but the male had left, you know, he left her early on. Yeah. Yeah. Yeah, by the time those larvae mature, that carcass is pretty much used up. Yeah. Right, right. Yeah. Yeah.
Why Black Island? And
It's a great question. So why are they there? I think they probably always were there. I mean, you know, going way, way, way back in time. And for some reason they were able to hang on there because I think some of the factors that affected the mainland populations weren't there, maybe. We know that the ones on Block Island mainly use birds, ocean birds, seabirds, sea nesting, whatever those birds are that nest on the island as hosts because they've done a stable isotope analysis. And there's so far, no raccoons on Block Island. So some of those main pressure things, some of those scavengers are missing on Block Island.
Plus they looked on other islands.
Oh, yeah, okay. So we just surveyed Plum Island, Fisher Island. Yeah, all those islands out there have been surveyed in recent years, and also the mainland, because the mainland's only 9 or 10 miles, right, from Block Island. So they're supposed to be monitoring along the mainland, and they have been monitoring and haven't detected any so far. But if the wind blew the right way, I think they could make it to the mainland. So that's, oh, they fly great. Yeah, they can fly 10 miles in a day easily. Yeah, so I don't know, you know, with the winds, if the winds are right, I think they could make it, but then would they be able to persist? Apparently they haven't yet been able to persist, even if they've made it. Yeah.
You know, this male and puts the pheromone out to tell its mate, you know. He recognized his mate.
I don't think he's very picky. No. Yeah. Now, there have been instances where a couple of females will show up and they'll fight. They will fight over the right to that carcass. And with these beetles, it's often simply the big one wins. the big one beats up the small one and wins. And it's the same thing with males. You know, if multiple males find a carcass, they'll fight. These things will fight to the death. And they're vicious, but it's usually the biggest one who wins. And they get the right to reproduce.
What if that was an issue in the traps if multiple get in at the same time?
Yeah. We check the traps right away in the morning. Yeah, they will. We put in the bottom of the trap, we have some moist peat moss, a couple inches worth, so they can, when morning comes, they kind of bury in and go to sleep. And we try to check the traps immediately. Fish and Wildlife Service says you have to check the traps, you know, immediately within like 2 hours of daybreak. Because number one, it can get hot. That was in Oklahoma, not here. Oklahoma, give it hot by 9 o'clock. And also so they don't kill each other.
Seen a male and female, maybe friendly, and leave together the next day.
Oh yeah, they're very quick to immediately mate as soon as you put them together. So each one has his own little cage in the lab. You can't put them together until you're ready to mate them. And then it's either they like each other or they don't. So, yes.
Rather indelicate question. I just have to ask, carcasses from for these
Oh,
ones you're rearing in the lab.
we buy it. We buy frozen rats. Yeah. Yeah, it's not pretty. Block Block Island, when they do Block Island uses frozen quail. You can buy frozen quail, apparently. And they've been using that. There have been lots of studies to see if they have a preference in carcasses, and they don't. So we have to buy them. Yeah. Yes.
You haven't released any yet. How many generations have you got?
So just one. We just got our founding population from Block Island a few months ago. It takes 1, 2, 3, about 3 months to make a generation. So this is our first generation. And we had planned to release them in June here at Greenwoods. And there was a holdup with our permit. And so they got it to the point, like I said, it's open for comment. They're going to do the hearing in July. It's going to be too late for us for 24. So these are going to have to go back, which we really, really hate, but at least they'll support the existing population. And then we'll get new wild-caught beetles again next January, February, March, April. Yeah, next January. And those will be our founding population for 25. Yeah, it was really unfortunate because we have such a huge batch of beetles that we could have released this summer if the system had worked. Because it's extirpated and I guess to release anything, you have to have a permit. You have to have propagation permits and release permits, and you got to have them at state and federal level. So our holdup was not with the federal permits; it was a DEC. Because it's extirpated, they wanted oh, actually, that's what it was. They wanted a safeguard. It's called an NEP, a non-essential experimental population, and that means that. Same thing happened in Oklahoma. People aren't liable. So if one of these ABBs, we release it and somebody accidentally kills one, they're not going to get sued by the government because it was an endangered species. And without that safeguard against liability, they were not willing to do it. And that's typically what happens with endangered species. Nobody likes endangered species on their property because it limits what you could do, right? You can't develop, you can't do this, you can't do that. And so this is the safeguard that gets around that. So we had to do that first. and we did, and now it's getting ready for comment, or now it's up for comment.
Did you have to do that too, or do you have a botanist?
No, I had to do everything. Matt Schlesinger has been my lifesaver in the DEC with the New York Natural Heritage Program. They're the ones who take care of the endangered species in the state. So he's helped me with that process in the DEC, but it's just been us. And the Fish and Wildlife Service have been extremely supportive because they're the ones who funded us. They're the ones who want the species to not go extinct. So we just have to get through the hoops, that's all. And I'm not an expert on permits, but Matt's been really, really helpful there.
Well, they're really fascinating creatures.
Yeah.
That's
Yeah, they're really
what
fun.
evolution does.
Yeah, yeah, they're really fun. And it provides that incentive to also conserve your, other species, right? Like the birds and the mammals. If those things aren't on the landscape, then the beetle can't make it either. So it works both ways.
Carmen, I'd like to thank you very, very
Oh,
much
sure.
for your expertise.
Thank you. Thanks for having me. Yeah, check out our Facebook page with the beetle pictures. This one. Yeah, there it is. ABB